Good afternoon. My name is Daniel Perez, and in this lab we investigated collisions and conservation of momentum and kinetic energy. The purpose of this experiment was to observe what happens to the total momentum and kinetic energy before and after both elastic and inelastic collisions using carts with the same mass and different masses. In physics, momentum is defined as mass times velocity, and for an isolated system, the total momentum before a collision should equal the total momentum after the collision. Kinetic energy, however, behaves differently. In an elastic collision, kinetic energy is conserved because the objects rebound without lasting deformation or significant heat production. While in an elastic collision, some of the kinetic energy is transformed into other forms such as heat, sound, or deformation. This lab allowed us to compare those ideas experimentally by recording and analyzing the momentum and the kinetic energy values in each collision case. The concepts tested in this lab can be applied in many real-life scenarios. One common example is a car accident, which is usually an elastic collision because energy is lost to sound, heat, and damage to the vehicles. On the other hand, collisions between pool balls are often treated as approximately elastic because they keep much more of their kinetic energy after the impact. Understanding the difference between elastic and inelastic collisions helps us explain how momentum is conserved in everyday events, even when kinetic energy is not. Thank you.
The footage that you're seeing right now is me and my partner trying to do the experiment, and we're currently looking at the following procedures that we were been told to do. Now, it took an extremely long time to do, and it took up a good majority of the class time that we were had. And so that if there is any error in the calculations or just like how we did it or like how it was executed, know that it was during this process that maybe something was misread or something didn't go right. It was mainly in here, and even our TA said something about the instructions not clearly saying something that we needed to do.
This one is for elastic.
Good afternoon, my name is Daniel Perez, and in this lab, we investigated how momentum and kinetic energy change during elastic and inelastic collisions. We used carts with the same mass and different masses, and compared the total momentum and the kinetic energy before and after each collision. To produce a relatively elastic collision, we arranged the carts so that they would bounce apart with as little energy loss as possible. To produce a relatively inelastic collision, we set them up so more energy would be lost during the impact. From our results, the percent differences were 47.6% and 100% for the momentum and kinetic energy in the same weight elastic trial, 100% and 100% in the same weight inelastic trial, 60.5% and 88.9% in the different weight elastic trial, and 47.4% and 60% in the different weight inelastic trial. A quantity is considered conserved when its percent difference is close to 0, because that means that the value before and after the collision stayed nearly the same. Since many of our values were far from 0, our data does not strongly support perfect conservation in this experiment. The theory says that momentum should be conserved in both elastic and inelastic collisions. While kinetic energy is only conserved in elastic collisions, our results only partially supported this because experimental errors likely affected the data. Some possible sources of error include friction, inaccurate velocity measurements, imperfect alignment of carts, and timing errors. Overall, this lab helped us understand that momentum is expected to be conserved. Kinetic energy depends on the type of collision, and the percent difference helps show how close our results were to the ideal theory. Thank you.